Good afternoon, everyone. My name is Amir Siduri, and I'm the R&D lead at CDL. I'd like to welcome you to the inaugural CDL Insights session. The title of the panel today is Life Beyond Earth. Now, as you are some of the busiest people on this planet, you might be hoping that CDL is going to give you an extraterrestrial escape plan. But very sadly, we're not going to be able to do that. CDL is not sending anyone to outer space. Not today. However, we're going to talk about why now might be the right time to focus on the implications of private space exploration. And leading this conversation is Colonel Chris Hadfield. As you all know, Chris is a former commander of the International Space Station, and he's the first Canadian to walk in space. Chris will contextualize the historical perspective of space exploration, and he will moderate the panel of Anusha Ansari, Dante Loretta, and Firuz Nadri. Please join me in welcoming Colonel Chris Hadfield.
Mina, thanks for the great lead-in. I think it's very useful and helpful. If you can bring up that slide presentation that I sent. Do you have it? Yes? If I click forward to it, is it there? Super. Okay. So I just wanted to give a little historical context that I think would sort of match what Mina was just talking about and some of the things that have led into it. And that is, how do you see yourself historically on the edge of a new age of exploration? And the way we're doing it in this room, the things that Ajay and all the team here have put together, I think was mirrored pretty interestingly 600 years ago when a group of people took the absolute best of the technology that existed. They looked at how could they push technology and vehicles to a new level and then see where that would lead us as a species. And here in Portugal, in the mid-1400s, a guy named Henry put those people together. He brought the latest in navigation ideas. He actually built a whole new spaceship, the thing called a caravella, a new design of spaceship that will allow to not only sail in shallow rivers, but to be able to beat the wind like they'd never done before. And then they started applying it to try and see how could you take this technology and change the rules as to what was possible for the people living in Portugal and everybody around the world. And he worked through the 1400s. He was an explorer himself. But it led to an enormous breakthrough in 1488 when the very first person sailing out of Europe was able to pass through the Cape of Good Hope and access the markets of the Far East with a ship that would carry the trading goods there and back. Bartholomew Diaz in 1488. But at the same time, because the idea was so new, it attracted people from all over to try and come to that version of a creative destructive lab and see if they could take their idea and apply it to new opportunities. And there was an Italian named Chris who came to Portugal with his ideas, but the Portuguese had just got access to the spice markets, and they weren't that interested in his idea of the fact that you shouldn't sail east to get to the spice markets, you should sail west. It's shorter, the world is round. And so he actually had to go and get funding from venture capitalists, from benefactors, from government, and from businesses. And in 1492, the results he got were not what he expected. But by taking the latest in the technology, putting together a package internationally, he did not discover the Spice Islands, but discovered a whole part of the world that we didn't even know existed. And another Italian came in with another idea, a guy named Giovanni Caboto, this guy. And he realized, boy, if you take a globe and you pull a string across it, the right way around the world is not following a line of latitude, but the shortcut is through Great Circle. And the further north you can go, the shorter it'll be to get to these new lands. The Portuguese weren't interested because they'd already invested. The Spanish had just invested in Columbus. So he took it to a whole new market in England, again applying to businesses and to venture capital and to government, got funding. They built him the spaceship of the day, which he called the Matthew, and he failed horribly. Sort of like Columbus had. Didn't get to the markets he expected. When he launched with the Matthew in 1496, he had significant failure, got blown out, barely got past Ireland. But in 1497, he managed to get another round of funding, launched again, and opened up the markets of North America to Great Britain, which changed history and established another way to apply this new technology to then start into exploration. And we're sort of in that stage right now in space exploration. It seems crazy. But what those guys were doing in the late 1490s was crazy. And yet they laid the groundwork for everything that has followed since, all of the opportunities. Where we are now is still pretty much defined and limited by the risk of launch. If you look at this version of Giovanni Caboto, the most experienced astronaut in American history is Peggy Whitson. She's spent 665 days off the planet. She's commanded the world spaceship twice, the International Space Station twice, NASA chief astronaut. But if you're trying to define an opportunity based on technology, I think Peggy helps put it into perspective. And that is, if you take her whole 57, 58 years she's been on Earth, and you try and draw a chart of the risk that she's faced, about half of all the risk she has faced in her entire life is in the 27 minutes that she had rockets firing underneath her. It is still incredibly risky to try and use this technology to push ourselves into an environment we haven't gotten to before. But that's a problem that can be solved, just like we've solved transportation problems in the past. And it's intriguing to me to see who is working directly on trying to simplify launch. Because if you can simplify it, and when we're talking as a group of folks here that have the ability to finance and research and push back the edge of technology, simplifying the technology then, of course, leads to decreasing the cost, but also improving the safety of it. And Richard Branson with Virgin, and Elon Musk with his space company, Blue Origin, Jeff Bezos with Blue Origin, and Elon Musk with SpaceX, all three of them are looking to reinvent launch, to make it simpler and therefore safer and therefore cheaper. Elon, and all three of them are chasing sort of the follow-on to what Mina was talking about, and that is dropping the cost of access to low Earth orbit such that it opens up all entirely new markets. They would all love to use this technology to put enough transceivers in low Earth orbit to be able to give us all Wi-Fi. And Elon has already launched on his rockets 2 of the initial test versions of that Wi-Fi network to give the entire world the ability to log onto Wi-Fi, and if their models are right, to do it for about the price of Wi-Fi that exists for the developed world right now, but to make it available to everybody. But the biggest technology change, I think, and also Peter Beck. Don't let me forget Peter down in New Zealand. He's approaching the target the same way. An amazing startup with this company called Rocket Lab. A small rocket, but using the lightest he can, 3D printing the engine, every piece he can. It's not a turbo pump engine, it's an electric pump engine, but he's already successfully got to space twice. And in New Zealand formed a space agency just to enable him as a new venture to be able to try and redefine the market of access to space. But what Elon said is, on the shuttle, those huge boosters that lifted me up on the 2 flights I was on, those big white boosters on the side, after they got us above the atmosphere, they'd plummet into the ocean. And the cost and the complexity of refurbishing those solid rockets to try and turn them back into something useful was prohibitive. And so what Elon challenged the folks at SpaceX to try and do, and some of the folks are very familiar, was instead of that first stage rocket that only burns for 2 minutes but gets you above the atmosphere, instead of it falling into the ocean, or for a lot of rockets, just get thrown away, what if it was possible to land it and retrieve it? make it reusable, and make it as simple as possible, almost an assembly line simplicity. And it's dangerous. It's going to fail, like almost all of the early vehicles did in its early efforts. But if you can make it work, then you have stepped forward into a capability that nobody's ever done before. But of course, you got to give something a try. At some point, you have to say, we're not ready, but hopefully we're ready enough to launch. And just a little over 3 years ago, for the very first time, Elon and his team tried to land a first stage rocket on a barge off the coast of Florida. This is just a little over 3 years ago, and this is how their first test went. The camera is mounted on the barge. So pretty good. No, come on. I mean, made it to the barge. But they had anticipated failure, of course, in their model. They realized they weren't going to get it right. They'd had multiple failures leading up into this, a few successes, but they learned a huge amount from this failure. They modified some stuff. They had a couple much less significant failures, and then just slightly over 2 years ago, for the very first time, on a day when the wind was blowing 50 knots, this is what the girls and boys at SpaceX did. And they landed it. And since that time, they have landed almost 25 of these. And they have gone from craziness, where everybody laughed at Elon just 15 years ago when he was talking about it, to told you so, he crashed, to, okay, well, they're getting close, to now suddenly the U.S. government, the U.S. Air Force is buying his rockets to put their most expensive payloads into orbit. And he took 3, I mean, these rockets are big. That's when they bring it back in. They found out when he brought it back in that you can just refuel it and use it again, that the pieces are still flight worthy. And so they've had multiple launches of the same rockets. There's now a used rocket industry that didn't used to exist. And just 4 months ago, I think as a lot of people have seen, they took 3 used rockets and did this.
8, side booster ignition. 6, 5, 4, 3, 2, 1. Ignition.
You've heard the call-out. Vehicle is supersonic. Operation.
Inside shut down. Inside boosters. Beacon. Center. South and up. S1 keeps going. Legs are deployed.
And the Falcons have landed.
So that's what we can do now. And this went from a standing start not very long ago right through to used rockets coming back and landing on the land again. And of course, he's not done. Where are the next destinations? And I'm going to bring a panel up shortly to talk about where we're headed with all this and what opportunities come from it. But where do you go next? Beyond low Earth orbit, to the moon, of course, is the next nearest object to go to. Elon's targeting the moon with this thing, which he calls the BFR, the big flying rocket. And I mean, it won't look like that. That's crazy, like everything else Elon draws at first. That's crazy. But it is not a very big stretch to think that some version of that could take off out of Toronto and be in London in 30 minutes. And maybe build a model that becomes profitable based on this technology, pushing it to the edge, rolling back to business opportunities here on the surface. And beyond that, of course, looking to take it even further out. How can we take the decreased cost of access to space into a bunch of different business opportunities, eventually going further out to access asteroids, the opportunity that's been discussed, and we'll talk about it more, about potentially mining asteroids, and going as far as Mars and beyond. And I think I just want to mention a couple things that have changed that I think define where we are in space exploration right now, sort of like 1490. Number one is that improvement in rockets, the change in the cost of access to space, and hopefully the improvement of the reliability of them. The funding model has changed. Amina talked about this a little bit. It isn't just the national-sized organizations that are funding spaceflight. We made the transition of private spaceflight for unmanned vehicles decades ago, where a private citizen can buy a private rocket and put something into space. But we're getting into the place now where that's maybe possible for humans on board rocket ships. We've also transitioned historically from exploration to settlement in space. And that gets lost, I think, in the day-to-day. But Peggy and myself and Anusha being up in the International Space Station, we started living permanently in space almost 18 years ago. In the fall of 2000, we permanently left Earth. And you sort of lose that in all the stuff that's going on in the news. But we have had people, there were 3 people left Earth this morning. We watched them at breakfast this morning to go up to the International Space Station. And that transition from exploration to settlement is the natural historic pattern, but of course it opens up an unimagined series of opportunities beyond the planet when you start settling in other places. Right now, just Earth orbit, but it's not that far to the moon. It's only 3 days away. And the technology is just about good enough to be able to access the moon, not just with robots, but with people on a permanent basis. I think that also has shifted public sentiment. You see it manifested in popular media, but it also has shifted the intention of all of the space agencies of the world. Every single space agency is talking about settlement as the next step and how we're going to do it and what is going to be the flow. Even the brand new space agencies, Australia just formed one. The United Arab Emirates have one. China is landing life on the moon later this year. They're on the far side of the moon. And they're putting a communication satellite around the moon later this month. The Indian Space and Research Agency or organization is landing on the moon later this year. So the space agencies are definitely changing. And then the last thing is the discovery of resources that we need in order to be able to live in a new place. Nobody could live in Toronto through the winter without technology. It's not suitable for this type of body. We need to be able to build shelter, we need to be able to harness power, and we need to be able to clothe ourselves, even to be able to live here. And that same application of technology, we just need the right resources in the place we go to, power and water, to be able to live on the moon. And there are ways to solve both those problems as well. So the opportunity for in-space or in-situ resource utilization, I think, is a game changer also. So that's where we are historically, and I'll talk about what we're planning here at the CDL, if that's okay, Ajay. But looking at this, the fact that it is kind of a moment of doors opening, we thought it would make a bunch of sense. Ajay and I have been talking for a few months to, in addition to all the other streams that CDL follows, to open up specifically a CDL space stream to look at opportunities. And some of them are going to be in launch technology, some are going to be in communications, in the actual hardware. As Mina mentioned, the folks at Planet Labs who spewed out all those little satellites, they image the entire world every day. The entire world every day is imaged on a steadily increasing database. The ways to take that amount of information and turn it back into something useful is a space application. And then, of course, working towards expanding the human presence beyond opens up all sorts of opportunities. So we're starting a CDL space stream, and when we pick up business in the fall, it'll be one of the streams that we'll be inviting entrepreneurs and inventors to be pursuing. So that's where we are. I would like to invite 3 people up to the stage. Who wants to come up first? Anusha, I think folks know, but Anusha has started a couple of very successful tech companies, and the Ansari X Prize, which has been a a model for how to be a catalyst for other people to invest and do something new. And Anusha flew on board a spaceship. She flew on board a Russian Soyuz and was on board the space station for about a week. So a person who really puts her body where her dreams are and took that chance and that risk. We also have Dante Loretta, who is a researcher and a professor down in Arizona, but also is involved in one of the really cool projects going on right now. In August, his invention is going to rendezvous with an asteroid that is orbiting the sun, and we'll talk about it in a minute, but to actually sample that asteroid and bring some of that asteroid back to Earth to try and understand what that means, what the opportunities are, what the resources are like, what the risk is to the planet. And then the third is Firuz, who has worked for, Firuz Naderi, who has worked in the space industry for his entire life, worked at NASA JPL, led all sorts of programs, space communications, but also in exploration of the solar system, and most recently in trying to figure out ways to get, sort of like Henry the Navigator, how do we take all of this technology and how do we apply it so that it can give us access to places we've never been before? In this case, trying to figure out a settlement plan to take us to Mars, using the technology of today and the probable technologies that are coming up. So I think, let's see, who shall I ask first? Dante, I will ask you first, if you would, please, just to talk about what's going on in your world and maybe talk about OSIRIS-REx.
Absolutely. Thank you for having me here today. This is my first experience with CDL, and it's already been inspirational. As Chris said, I'm the leader, what we call the principal investigator for the NASA OSIRIS-REx mission. I wouldn't call it my invention because it's the culmination of a hard work of thousands of people all around the globe. I just have the honor and the privilege of being able to lead the expedition. I started working on the program in 2004 when I was first invited to join the proposal team. Took 7 years of proposal writing to convince NASA to fund the program. It's $1 billion, all said and done, of US taxpayer money. We have major partnerships with the Canadian Space Agency, and in fact, a device that was built just not too far from here at MDA in Brampton. Their laser altimeter is on board the spacecraft, so Canada's got a major role, so you're probably going to be hearing a lot more about the mission as we arrive at our asteroid. We launched in September of 2016, and we've spent the last couple of years cruising through deep interplanetary space. And in August, just a couple of short months from now, we're going to get our first images of the asteroid, beginning about a 3-month-long approach phase. We will rendezvous with the object in December, and we will spend all of 2019 mapping the object at exquisite detail down to, in some cases, millimeter resolution, ultimately selecting a spot on the asteroid surface to fly this perfectly good spacecraft down to make contact with the asteroid, collect up several hundred grams of material, and tuck it away for a journey home. We leave in March of 2021, and the samples come back in 2023, giving us 2 years of funding for sample analysis. But of course, the samples will be archived at the NASA Johnson Space Center, as well as a portion transferred to the Canadian Space Agency. And researchers and interested parties for generations will be able to access this material to understand the nature of this asteroid. The mission is science-driven, and my interests have always been in origins, understanding the origin of the solar system, the origin of life, and our asteroid was chosen particularly to address those questions. But it also has a lot of technology that feeds forward. We are a resource identification mission. We are a pathfinder for asteroid mining, and I've gotten involved, and that's actually why I'm here today, I think, is because I've been working in the asteroid mining industry, taking what we've learned of the challenges of operating a spacecraft in microgravity around an asteroid, surveying it, and then collecting material, and trying to push that technology forward into an industrial sector. A lot of challenges there, but this is $1 billion of investment. We should definitely be leveraging it for more than the scientific return of the program. And then, of course, when the media gets interested in the mission and they ask me what I do, really, I'm just saving the world from asteroid strikes. The asteroid has one of the highest probabilities of striking the Earth. The good news is you don't need to run off and buy asteroid insurance, although it might be a business model we could pitch at CDL next year, because the impact's about 150 years in the future. But it is a big object, relatively speaking, 500 meters in diameter. It would create a 3,000 megaton explosion were it to enter the Earth's atmosphere, causing widespread damage and a large natural disaster. So the technology that we're developing is also critical for asteroid deflection and asteroid trajectory prediction and figuring out how you could mitigate such an event if it were to come our way.
Thanks, Dante. So I want to come back to a couple of things later, but first, Firuz, the step after space station, maybe settling on the moon next just because of the ease of proximity, but eventually going on and putting robots, ever more complex robots onto Mars, and eventually people on Mars. You've been working on it for a long time. Could you just give us your perspective on where we are in that and what are the biggest challenges, but also opportunities that face us as that's being pursued?
Yeah, sure. So when we go to Mars, and by we, I mean the people of the planet Earth, that would be the most complex project that humanity has ever undertaken. It's maybe ways off. There are some challenges, technological challenges. There are other challenges that people to each side of me can talk to, biological, because in trying to go to Mars, you can't just pack up and go anytime that you want. You have to wait for the alignment of the planets be such that you can actually go, and that comes around every 26 months. And it takes only about 7 or 8 months to get to Mars. But then once you're there, you have to wait for the alignment to form again before you can come back. So the round trip is about 3 years. Right, so that's almost 1,000 days. And we haven't experienced that. We don't know how to send astronauts and bring them safely back home yet, biologically. Psychologically, they can talk to, I mean, they have been to space station, but going to Mars, there is a total separation from the home planet and total isolation, you know, for 3 years with 2 or 3 or 4 other people. And, you know, overcoming that is also an issue. But given where we are, let's focus on the technological aspect of this. So to put it in context, we have landed on Mars a bunch of times. We have failed much more times attempting to land on Mars. And the problem is that when your spacecraft approaches Mars, it is going at 20,000 kilometers an hour, and it has 7 minutes to put a brake on this spacecraft traveling at that speed to a soft landing, or you're going to make $1 billion crater in the surface of Mars, and a bunch of people will not be happy with you. So because of that, and by the way, we have never lifted off anything off the surface of Mars. The only time we have done it is in the movie Marshall. Hollywood has a way of solving these issues for you, but we have never lifted off the surface. So the biggest thing that we have landed on Mars, we landed in 2012, and it weighs a ton. It was the Curiosity rover that we landed on Mars. So the reason humans landing is going to be that much more difficult is that you're going to need about 20 times that, about 20 tons to land on Mars. And it gets a lot harder to slow down that speeding train of 20,000 miles an hour if it is, you know, if it is that big. And then once you get on Mars, as Chris pointed out, it is practically impossible to take everything from the Earth that you're going to need to live off Mars. You have to produce your own oxygen. As you know, Mars is 99% carbon dioxide, so you have to produce oxygen. The good news is that you can extract that out of the atmosphere. And in a couple of years, in 2020, we are sending a prototype of something that's going to produce oxygen on Mars, and hopefully then scale it, you know, for the eventual thing. You have to make your own fuel, you know, to get off the surface of Mars. Now, in the process of developing the technologies that you need for doing that, I believe just talking to someone over lunch, over breakfast this morning, and then Mina talked, I can tell you that there is, I mean, at first, it doesn't sound like there's a connection between traveling and Mars and CDL, but there is. Because smart people like you will find a way, as the governments are planning to go to Mars and develop technologies, you'll find a way to spin it off and find applications here on Earth for it. So I'll give you 3 examples, and then I'll stop here. So one example is Elon, right? Brilliant man. And most people think that Elon is building this and Elon is building that. Well, actually, he has figured out a very smart business model. He, to be sure, he put at risk money hard-earned in PayPal. He risked that to build his MVP. But once he had his MVP, he got billions off of the governments. So while everybody thinks that Elon is doing this and going to Mars, it is the space agencies that are funding it. And so he found a way to make money in the space agency. And unlike some other things, you don't need millions of customers. I mean, if you have a few space agencies willing to give you the kind of sums that he's getting, that would make a successful mission. So that's one. The other thing is that when we eventually go to Mars, there is no rocket big enough to lift the kind of things off the Earth that we have to take to Mars. So you will take them in pieces, and then when you get to high orbit, you rendezvous and connect them together. And then you need a tug to tug these assets all the way to Mars. And so one thing that we learned this morning, a young man out of Colorado is working on nuclear electric propulsion, which would have the capability of tugging all these heavy assets.
That's someone who's here today. Right?
That we talked about, yes. And then finally, just to connect it to what Mina had to say about these CubeSats, small sats. So as we speak, there are 2 of these little guys on their way to Mars. They are not as small as what Mina showed. He showed a 3U CubeSats. That's a 12U CubeSats. But because it has to survive, by the way, all the CubeSats that are being built right now, it is for low Earth orbit, right? Building something that's going to go millions of miles away to Mars, everything needs to be better. You need better antennas, you need better radios, you need better computers. And as they build it for that purpose, that becomes all available to be used on these small communication satellites on Earth. So when will it happen? It depends on the stable policies of the governments. You know, we were going to go to Mars, and then we were going to go to the moon, and then we were going to go to the Mars. But then, oh, that was Obama's plan. I need my own plan. Let's go back to the moon again. So you don't have the stability in a government policies that would require it. So that may be the biggest impediment. But Elon has said, oh, we're going to go there in early 2020s. And in addition to being a brilliant technical man and a brilliant businessman, he's also a brilliant marketeer. And so that's not going to happen. And not on the time frame that Elon is talking about, but he has the attention of the world on him, and you know, what a good businessman he is. But I think it is conceivable. I mean, the last thing I did before I left NASA was to work on an architecture to go to Mars without breaking the bank, meaning NASA's budget would need to double or triple in order for that to happen. I think it is possible to take going to Mars and break it into half. The first part is to go to a moon of Mars called Phobos, land there, find out all the transportation that the astronauts need to, to perfect, making sure that we can get them then and then bringing them back safely. And then the second part would be to actually master going down to the surface of Mars and then lift off from the surface of Mars. I think the first one, going to Phobos, is probably late 2020s, early 2030s. That is possible. And then actually humans landing on Mars, that may be a few years after that.
Thanks, Guru. So what we basically just looked at was the traditional, historic, science-based model of doing something off the surface of the world, like happening with OSIRIS-REx, International Space Agency cooperation, including Canada, the CSA, a multi-year billion-dollar mission, but doing something that couldn't be done any other way. And then what Firuz is talking about is a space agency-driven model for the next step in human exploration, like has taken us so far. But I think because of the change in rocket technology, but also just because of a change of public perception and opportunity, there are other ways to do those things. And Anusha, if I can ask you, please, you had the vision to think about what the Ansari X Prize not only could be in the short term, but what sort of role that could play, an example that could set, if you could talk about that and where it's brought us today.
So before I start, I'd like to ask you guys some questions. So how many of you grew up wanting to go to space? How many of you thought that by the time you're adults, there actually will be a settlement or a way for you to go to space? How many of you have invested in some kind of a space venture? Oh, good, a few. How many think in the next 5 years you would invest in a space venture? Good. Well, I hope that by the time we finish and we start in fall, many more hands will go up, at least on the future. But like many of you, I grew up dreaming of going to space. I watched Star Trek. I thought that by the time I'm an adult, there will be a Starfleet Academy, and I will, study and become a science officer on board Starship Enterprise. Of course, didn't happen, so I had to go about it in a very roundabout way. Like any, good Iranian daughter, I listened to my mom and studied engineering because I could get a good job and support the family. So that's the route I took, and through that process and becoming an entrepreneur in the telecom industry, I saw how competition in the telecom industry completely transformed that industry. When I landed in the US, every time I wanted to call home, I had to pay like a couple of dollars a minute to pay for that phone call. By the time we sold our company, which was in the voice over IP business, the cost was going down to zero. So in 2000, I met someone who changed the trajectory of my life and helped me achieve my dream of going to space, and his name was Peter Diamandis, who had dreamed of a competition to really bring attention and focus to solve the problem of access to space. Because the reason no one had done this before was the cost of access to space was very high, and the only entities working on solving these problems were governments. So as long as governments were the only players in this market, he knew, and all the entrepreneurs around the room know, that the cost would not come down. So with launching a prize, we thought through competition we can solve that problem. And he met me in 2000, read about my passion for space, and pitched me the idea of the prize, and I partnered up with him and been part of X Prize Foundation. But when we launched the prize, which was a $10 million prize, it attracted about $100 million in investment that actually helped shape this whole industry. And not only brought attention to solve this problem, it brought a lot of innovation, but more importantly, the work we did in the 10 years that took to win the prize around the regulatory reform, actually education of the public, was transformational in helping these companies that we see today build their product. So it's something that we see happening now, and there's the next wave of it coming. So in the past, I think, decade, Mina talked about the $4 billion in investment. The total investment is closer to $15 billion, about more than half of it in US, and then I think UK is next. But there's a lot more attention now given to space because there's a business case that's being made out of the technology. And there are many, many ways to approach it. Some people listen to Firuz and think about all the issues and challenges, but the entrepreneurs around the room will actually look at it and see each one of those challenges as an opportunity they can attack and solve. And I believe it is crucial for us to solve those things because many of those solutions have applications here on Earth. Being able to live in an environment in Mars will become very important, especially if we continue with our environmental policies to figure out how to actually have a safe environment for us here on Earth, that we can reuse resources and be able to survive in a closed sort of system environment. Propulsion is another area I particularly am very interested. While I'm fascinated and love what SpaceX and many of the other rocket companies are doing, I love to see a different way of going to space and see new technologies developed in that area. Being in the telecom market, and everyone talking about the cloud, we're talking about there's, of course, technology challenges, but if we can overcome the round-trip delay of satellite communication, is there a way for us to actually put the cloud above the clouds in space where it's cold and there's plenty of solar energy and to reduce the cost of creating something like that, maybe for storage purposes or other purposes. So there's tons of application that's not necessarily about settlement outside of our planet, but also uses of space that will benefit us here. And I hope that the entrepreneurs that will participate in this space stream will actually come up with a lot of interesting answers to those challenges.
Thanks, Anusha. Dante, what you're essentially doing here, starting in August at least, and then when you do the sampling, is you're the very first space miner, sort of, or mining an asteroid at least.
Remembering that the Japanese are also operating a vehicle around
That's
an
true.
asteroid. So there's going to be 2 missions around asteroids. In fact, they just arrived last week, so they're a couple months ahead of us.
But space mining is gotten a lot of attention. There's basically an unlimited amount of raw material beyond our atmosphere, but it's extremely difficult to access, as evidenced by the OSIRIS-REx profile. But if you could just talk for a minute, what are the limiting technologies or the technological advances that you think need to be made, but also if you're an entrepreneur or someone is looking at backing an entrepreneur, what are some of the ones that might be crackable or that we can start nibbling away at to improve access to eventually get as far as profitable asteroid mining?
Yeah, I've been asked a lot in the media and now with financial services that are investigating this and putting out reports about asteroid mining. And the one commodity that makes the most sense right now is water. So we're not talking about going to get water and bring it back to the Earth. In fact, I don't see a business case right now where you take anything from an asteroid and bring it back to the surface of the Earth. There's not a need for that right now. But water is easily broken apart into hydrogen and oxygen. Hydrogen and oxygen are the most powerful rocket fuels that we know of. And in fact, we talked about the reusable launch vehicles. Chris showed us the Falcon first stage is coming back to Earth, but the second stage is not recoverable right now. And I know the competitor to SpaceX is the United Launch Alliance. That's the vehicle we launched on, their Atlas V. Their second stage is powered by liquid hydrogen, liquid oxygen. Those second stages are usually, if they're going into Earth orbit, just deorbited and also discarded into the ocean. In the case of OSIRIS-REx, because the second stage pushed us onto the interplanetary trajectory, that second stage is now just flying through the solar system. It's a perfectly good engine. If it could be refueled with hydrogen and oxygen, it could be reignited and could take you lots of places in the solar system. It's incredibly powerful when you're talking about the low velocities you need once you're in Earth orbit to get other places in the solar system. So already United Launch Alliance has put a price on refueling a Centaur second stage from their Atlas vehicle. So if you could deliver that water to them in low Earth orbit or a Lagrange point in the Earth-Moon system, or boost up from LEO to the geocentric orbit, where a lot of the critical weather satellites and communication satellites are, there's a business case that already exists for that. The asteroid we're going to, asteroid Bennu, we believe is rich in water, which may sound strange for a pile of rocks, but we think some of those minerals are clays, and clays have water in their crystal structure. You can heat them up and drive that off. So the real technical challenge is not getting to the asteroid. We know how to do that. It's not collecting material. You have to scale it from a few hundred grams to tons, but it's cracking that water out of there and then distilling it, because when you heat up an asteroid to get off water, you're going to get a lot of other nasty stuff like sulfur and lead and mercury and things you don't want. So you got to distill it or purify it in some way, and then deliver that back into the Earth-Moon system, I think, for your propulsion systems.
Thanks. I personally, listening to what Firuz said, I do not think that we will go to Mars with the engines that exist today, because it takes years to get out to the asteroid and back, and on the order of years to get to Mars and back safely. And the complexity of exposing the human body to the environments that exist, but also the complexity of designing equipment that can 100% or close to it be relied on to keep people alive for years at a time becomes prohibitive to guarantee enough safety that anybody's going to pay for it. So I think we will go from the space station, which is there at least till 2024, but it was built to last till at least 2028. And you read 2024 all the time, but that's just as far as the United States and Russia have agreed to fund it jointly. The people that are going to decide that are not currently in power, at least not in the US anyway. So I wouldn't bet on 2024, but to me, the place that we're going to have to do a lot of the testing is on the surface of the moon next. But what I wanted to ask you, Firuz, was there are obviously obstacles, protection from the radiation environment, from the micrometeor environment, but instead of seeing those as obstacles, as Anusha said, if you're looking at it from an inventor's point of view, what opportunities are there? What are the problems that need solving in getting further away from Earth than just Earth orbit? Getting to the moon, landing on the moon, what are some of the technologies or ideas or things that will guarantee human health that people can be working on?
Yeah, well, you alluded to one of them, and that was the in situ resource utilization. Again, you would have to produce water, you have to produce fuel, you have to produce oxygen once you land. You cannot take all of that with you. I don't know, once we start working on those technologies, how you all will find a way of turning it and twisting it and giving us something that it is needed right here on planet Earth. That if history repeats again, you'll find a way of doing that. There's been a lot of spin-offs that it's in your everyday life, you don't even know about it, in your medical life, in everything that came out of the space industry. So first of all, I'm glad that you have decided to include that as a track in CDL. I think it would present a number of opportunities. I do want to give a shout out to another company again in space, just to show you how rapid things happen. Right, a mentee of mine, almost exactly the same age as Mina, graduated from Stanford 2 years ago, called me and they said, this company is offering me to make me the director of marketing. And I said, well, that's good. How much are they offering you? He says, well, 0.2%. I said, you crazy? You're going to go to this thing for 0.2%? He says, where else am I going to be right out of the school, be director of marketing? So anyway, we talked him out of it, and that guy has started a company 2 years ago, again, from a napkin, right? And to build a CubeSat, the sort of things that Mina is talking about, except to have a synthetic aperture radar on it, which was unheard of because synthetic aperture radar is a power hog. And you never would think that that could be done on a CubeSat. But he found a way of doing it. And I think if he closes his next round by September, which would be 2 years from the call that he gave me wanting to take a job for 0.2%, I think the valuation of his company in 2 years is about $200 million. And you know, sky is the limit for him. So space definitely, you know, I mean, don't be daunted by some of the, you know, the bigger technologies would be solved, you know, maybe by big private sectors, but along the way, there are many applications that you can fund and you can participate to both your benefit and to the benefit of society.
Thanks. I think some of the other technologies we're going to need in the continued exploration, of course, power generation. There is an enormous need for different ways of collecting power in order to power the satellites themselves, but any sort of settlement on the surface of the moon. The moon turns once every 28 days, so it has a 14-day night and then a 14 human or Earth day. So you have 14 24-hour periods of night if you're anywhere around the equator. Of course, if you're on the North Pole, you get 24-hour sunshine. So the ability to be able to deploy and generate power somehow on the surface, whether it's through the recent research that NASA's doing in trying to put nuclear-based power on the moon, or whether it's going to be solar, there's lots of opportunity there. As Firuz said, in trying to figure out how to do in situ resource utilization, all of the space agencies are going to need that problem solved. And they've got partial solutions, but clever ways to do it and proven ways to do it are going to be critical to the next step. It's maybe worth looking at, too, that as soon as you have gotten to the moon and you have a guaranteed power source and you have a water oxygen source so that you're self-sufficient, you are now independent of the Earth. You're no longer relying on a resupply chain from the planet. It changes the model. It's not like we've always done it. The space station costs a fortune because every single apple we eat up there has to be accelerated up to speed and brought and delivered on board. We don't grow crops on board the space station that we eat. The regular living is not the purpose of that vehicle. But what we set up on the surface of the moon will be. It'll be an independent, permanent colony on the moon, self-sufficient and separate from Earth. There's biological work that needs to be done, but how deep does regolith need to be on top of your habitat? How do you look at historical settlements that have failed? How can we avoid that happening as we slowly or rapidly progress to the new environment? And I think each of those little pieces opens up opportunities. Anusha, the example that you've set, I think, is also important. The work that you've done in telecom, but then turning that around in order to inspire other people to do things. When Elon talks about going to Mars, to a large part, that is just inspiring people. If he talks about, I want to decrease the cost of delivering something to Earth orbit by 3%, nobody in his company is going to be inspired. Right. But if people know that they're working someday towards living on Mars, and for now we need to solve this problem, it changes people's perspective. And you've been so significant in changing people's perspective. If you could talk about where you think we ought to be going next in that side of it in order to generate interest and ideas.
So just maybe a couple of other technology or breakthroughs that we need or interesting ideas that for entrepreneurs to work with. I think it's important for us to figure out a way not to have to carry everything with us. So 3D printing or additive manufacturing is something that we started using here. There's also a company made in space that also flown 2 3D printers to the space station. So we are starting to use 3D printers in space. So being able to actually manufacture, print things where we want to settle is interesting. Another sort of mind twister when you start looking at regulatory environment and again legal aspects. When you're completely independent of Earth, can you just claim that as your own new country, planet, whatever? So a lot of questions needs to be answered, which we have plenty of time to answer those. But in terms of what we've learned at X Prize is that there is no challenge that a passionate and focused mind can't solve. So bringing attention to and painting a picture of what future of humanity outside our planet could look like, how it could help our lives here on planet Earth, and painting that picture by itself will actually bring a lot of people together. Space has played a huge role in unification. You see that even though the space race started between the US and Russia many years ago, at the same time, many of the collaboration between Russia and the United States started in space. So it has been a unifying factor. You have 16 countries collaborating in ISS. So I think, again, for us to be able to have a settlement outside of our planet, it can be a unifying factor amongst many different space agencies. Young people get excited about science and math when you relate it into space technology. So, getting people, especially young women, which I'm very passionate to get more involved in technology, interested in space, we can see a lot more interest and involvement. So as you said, inspiration is important. The fact that the space agencies have opened up now and they collaborate and work with private industries is critical for the growth and future success. And I think it can be a source of early revenue and early adopters of the technologies that will be developed here in this room and amongst the entrepreneurs here. So I think there's a lot of activity going on. So places like CDL, where this type of activities can be amplified, that we can tell everyone about what's happening is important. I remember when we first started our involvement with the X Prize and we announced the prize at dinner table, this is early 2000s. When they asked my husband, what do you guys do? He said, we'll build rockets in our garages. And people would just completely think we're nuts. But there were people actually building spaceships in their garages. And many of the people who participated were the most unlikely people, not rocket scientists, who solved many issues that then other companies have sort of acquired. So it's important for us to open this up to everyone and make it really accessible for everyone to participate in this, and not make it so narrow focused and sort of elitist, where only rocket scientists, the super smart, can do this. This is really, some of the problems are problems that requires multi-talents around exponential technologies, robotics, AI, and psychological issues, human issues, biological issues that has to come together to make this happen.
Thank you, Anusha. We're just about out of time. Just one last point I wanted to make, and that is if you picture that our rockets are just about to get both technologically and financially viable to get us to orbit and potentially to the surface of the moon to stay, how do you balance out robotic exploration and construction versus human? And when is the right time for people? And with the improvements of robotic technology, but also the fact that we can increase their decision-making ability with AI, I think the pattern that's actually going to happen is to do the first landings robotically, like we've done on Mars, but to do it with the intent of building a human survivable habitat. We're going to have to build a power collection source robotically. That's going to push the edge of our ability to design those little machines. Once they can generate power, then use that power. How are you going to transport that power around? Is it batteries? Is it fuel cells? Is it something else? And then digging into in situ resource utilization, prospecting, and then finding water, and there's significant reserves of water on the moon, and then turning that into a hydrogen-oxygen resource, and then setting up, of course, communications and navigations infrastructure on the moon. That is another perfect task for small, ever increasingly capable robots, and then putting a habitat on the moon so that when we launch people, it won't be like Magellan in 1519, who did the first circumnavigation of the world, launched with the best of the technology that Portugal and Spain had brought forward, and yet it took 3 years to go around the world. They launched with 5 ships, 250 people, and they lost 4 out of the 5 ships. Only 16 people made it back. We can defeat that by using the technology that we've invented. From the time Magellan went, every long sailing voyage had scurvy on board for 200 years. And it wasn't until someone dug into the science of how the human physiology works in order to realize that we could defeat scurvy, and Captain Cook, who Botany Bay and all of that, was the first circumnavigating crew of the world that solved that medical problem. And I think we're at a position right now, pushing the edge of our technology to start including the rest of the universe in what humans can experience in person. And I think there's tremendous opportunity, and I'm really looking forward to the folks who are going to submit ideas starting in the fall for the CDL Space Stream. Thank you very much for joining me on stage. Thanks, everybody.